In this lesson, we're going to learn about decrease problems by looking at an example. The problem reads, in a recent test of an automobile anti-lock braking system, or ABS, on wet pavement, the stopping distance was 114 feet. If this was 28.75% less than the distance needed to stop the same automobile without the ABS, find the distance needed to stop without the ABS. Now, as you're probably aware, anti-lock braking systems have been around for, say, 10 or 20 years. And the purpose of these systems is to allow vehicles to stop more effectively. So generally speaking, systems with ABS should require less distance to stop than vehicles without ABS. So keep that point in mind. Now, what are some of the key points of this problem? Well, first, the vehicle with ABS had a lower stopping distance, in this case 114 feet, than the vehicle without the ABS system. In this case, the stopping distance of the vehicle without ABS is unknown. Since we're trying to find the distance needed to stop the vehicle which did not have ABS, we're trying to find the stopping distance before there was a 28.75% decrease, which is the base. So the original value is the base, and so this is a decrease problem. So again, with both increase problems and decrease problems, we're trying to find the base. And so since decrease problems are base problems, we need the equation we use to find base. So base is equal to part divided by rate. Now, how do we get the rate? Well, if you recall, with an increase problem, we took the actual rate and added it to 100%. So with decrease problems, we're actually going to do the opposite. We're going to take the given rate and subtract it from 100%. So that's the key difference, or a key difference, between increase problems and decrease problems. With decrease problems, you subtract the given rate from 100%. So in this case, the rate we will use is 71.25%. I'm going to have to scroll down a little bit. The part is 114 feet, which is the stopping distance after there was a 28.75% decrease. Keep in mind that the 114 feet was the stopping distance for the car which had the ABS system. So as a result, it was actually lower than the stopping distance of the car that did not have the ABS. So keep in mind that with both increase problems and decrease problems, the part is always the new value. In this case, it is the stopping distance after there was a 28.75% decrease. Okay, so how do we compute our answer? Since base is part divided by rate, we take the part, which is 114, and we're going to divide that by the rate, which is 71.25%. Again, any computation involving percents requires that percent to be expressed as a decimal or a fraction. So in this case, I rewrote 71.25% as 0.7125. And then, using my calculator to do the arithmetic, we see that the base, which is the original value, the value before the decrease occurred, turned out to be 160 feet. So after we installed the ABS system on the vehicle, we see that the stopping distance decreased from 160 feet to 114 feet. So again, the 114 feet was the new value.